In this problem, we're asked to consider the sinusoidal voltage Vt is equal to 100 times cosine 240, and there is an error here. This should be 240 pi, not just p, times t plus 45 degrees, and this is in millivolts. First, we were asked, what is the maximum amplitude of our voltage? Well, we know that V max, if we look at the notes link in the description for this formula, we know that our V max is going to be this value right here in front of our cosine or sine, depending on how it's written. A sinusoidal voltage is either written with a cosine or a sine. So this is our max, 100 millivolts. Now we're going to look at B, and B is what is the frequency of Vt in hertz. Now, to calculate for frequency, there's also a formula linked in the notes in the description again, where we have our omega equal to our 2 times pi times our frequency. Well, we know our omega to be this 240 times pi. This is our omega. We can see that from the notes, the formula that's given. So we are going to write this as 240 pi is equal to 2 pi frequency. And if we divide everything out, we are going to get that our frequency is equal to 120, and this is in hertz. Frequency is measured in hertz. So if we erase this, we can see that 120 hertz is our answer. Next, we're asked, what is the frequency of Vt in radians per second? And we need to find this in omega. So we just wrote the omega formula right here. Omega is equal to 2 pi f. Well, we know omega just by looking at our equation is 240. Correcting myself in my wording, our omega is not just the 240, but it is the 240 times pi. It's that entire part. So if we calculate this as 240 times 3.14159, or pi, this is going to give us approximately 754 radians per second. And that is the answer here. Next, we were asked, what is the phase angle in radians? Well, our phase angle, if we look in the formula, again, linked below in the notes, is this last part right here, this 45 degrees. This is our phase angle. And for the degrees part, for part E, if we erase this, we're going to see that we get 45 degrees. So for part D, all we have to do is convert this to radians. To convert anything to radians, we're just going to have what we want to convert out front, multiplied by a pi over 180 degrees. And this will give us the value of approximately 0.7854. And if we plug this into a calculator, we are going to get 0.79 for our radians. And that is the answer for this part. Next, we're asked to find the period in milliseconds. So we know that our period from a formula, again linked in the notes, is the inverse of our frequency. So we can say that t is equal to 1 over f. And we know that our f is this 120 right here. So we're really just going to have 1 divided by 120. And this is going to give us approximately 0.0083. And this is in seconds. T is always measured in seconds. So to get this in milliseconds, we're going to multiply it by 1 milli over 10 to the negative cubed. And if we flip this over, we are going to multiply by 10 cubed. So we're just going to move our decimal 3 places to the right, and that's going to give us approximately 8.3 milliseconds. If I erase this here, we can see that that is our answer. Now for part G, this is kind of the biggest part. What is the first time after t is equal to 0 that our V of t is equal to 100 millivolts? So we're going to plug everything in and then solve for our t. Plugging this into our original equation, we are going to have 100 millivolts is equal to 100, and this is also in millivolts, times our cosine, and then inside of here we have our omega, which is 240 times pi, times our t, plus 45 degrees. Now, we want to solve for this in radians, so we're going to convert 45 degrees to radians. If we do this conversion, or if we just look at a graph, we can see that this is going to be a pi over 4. So this is the conversion from 45 degrees. Now, if we cancel some things out, we're going to get a 1 is equal to our cosine with everything inside of it. So now we know that everything inside of our cosine has to somehow equal to 1. So whatever any of this equals to, our cosine must equal 1. And the places where our cosine is equal to 1 is only at 0 and at 2 pi. So if I'm to graph this like this, and we have our 0 degrees here, we have 90 degrees here, we have 180 here, and 270 here. Well, for the first time, we know that t is equal to 0 here. But if we go around another time, t is also equal to 2 pi. So the first time after our 0, where cosine of whatever is equal to 1, is going to be 2 pi. So we can basically say that 2 pi is equal to our 240 pi times t plus pi over 4. Now from here, I'm going to divide everything by our pi just to get rid of it, and then I'm going to move the constants over to the left side and solve for our t. If I do this, I'm going to get 2 minus a 1 over 4, and then divide it by 240 is equal to our t. And then we're going to get approximately 0.0073. Now this is in milliseconds. So currently it's in seconds. We need to convert this. We know 1 milli is over 10 to the negative cubed. So we're moving our decimal place 3 places to the right, and then we're going to get 7.3 approximately. If I delete this, we're going to see that our answer is 7.29, so basically the same thing in milliseconds. And that's how you would go about solving this problem. If you have any questions about this problem, you can leave them in the comments below. If you want more introduction to circuit analysis and sinusoidal voltages, there's a playlist in the description, as well as notes that'll go over the entire coursework for this material.